Hi dear students, in previous lecture we have studied time division multiplexing. So today we are going to study WDM, means wavelength division multiplexing. So better I will explain it with diagram first. So it is similar to frequency FDM. So here what happen is, this is the wavelength of channel 1, means user 1, wavelength of user 2 and wavelength of user 3. So these waves are combined using WDM, means wavelength division multiplexing. So they have different wavelengths. Signal 1 means user 1 signal have various wavelengths, signal 2 wavelength is different and signal 3 wavelength is different. So those all wavelengths are combined and they are transmitted as a single wave. Clear? And at demultiplexing, the combined wave is retrieved with various waves. So it is passed to receiver 1, the second wave is passed to receiver 2 and third wave is passed to receiver 3. Clear? Only the difference between FDM and WDM is, FDM uses analog signals and it uses coaxial cable for transmission, whereas WDM means wavelength division multiplexing uses optical fiber for its communication. Clear? So wavelength division multiplexing is related to physics concepts. It is related to physics concepts. So you might have studied in your PU or in your high school that when a white light beam goes through a prism, it separates into individual colored light beams by the prism. So each light beam has different wavelengths. So for example, see here. For example, see here. So you might have seen the prism. So prism is in triangle shape. Okay. So when light beam, a single white light beam is passed through that prism, what happens is that prism will separate that single white light into different light signals. So from that we get total 7 colored light, WDM. Okay. So WDM you understand, no? So that WDM separate different colored light signals we get from prism. So why from white light, how we can get different light beams? Because in that white light many lights are combined which have various wavelengths, and those wavelengths are separated using a prism. So here this is the first colored light. It has its own wavelength. Like that for second, its wavelength is different. So that may be 0 to 10, 10 to 20. Again we have to assume. So first light may have the wavelength as 0 to 1, then 1 to 2, 2 to 3, 3 to 4, like that. Various light beams have various wavelengths and that is separated using a prism. Okay. Now what I do is, I will keep one more prism here in a reverse direction. So another prism is like this, and consider these all light beams, various colored light beams are transmitted through that prism. Then here demultiplexing means this reverse prism, what it will do is, it will combine various light signals into again a single white light beam. Single white light beam. Understood? So this is what WDM. So in WDM, multiple light beams from different channels are combined using a multiplexer and sends them as a single light through a optical fiber. Clear? So WDM is similar to FDM, but the transmission occurs through optical fiber. In WDM, the transmission occurs through optical fiber. WDM uses optical signals in multiplexing and demultiplexing. Examples for WDM is FTTC, means fiber to the cabinet. It is the WDM technique used for optical fiber communication and copper wire. So now let us see WDM with one more diagram. So consider here different transmitters are there. Transponder 1 means first transmitter, transponder 2, 3, 4. They are transmitting their own light beams using a optical fiber. In multiplexer, all light beams are combined and transmitted as a single light signal. So demultiplexer will separate those light beams and transmit it to the respective receivers. Transponder 5, 6, 7, 8 means they are the receivers. Clear? So why we use optical fiber here? Because we are transmitting data as a not electric signal. We are transmitting data as a light signal. And whenever light signal is transmitted, we need to use optical fiber, because coaxial cable and twisted pair, they transmit electrical signals, and only the optical fiber can transmit light signal. So that is why in wavelength division multiplexing we use optical fiber to transmit data as a light signal. Clear? So here transponder 1 is sending some light beam, means that light signal is consisting of some data. That may be analog data or digital data, that may be text data or image data, but it is consisting of some data. Understood? So best example for this one is theater, picture theater. So from back side, from the center of it, you get one light beam that is displayed on your screen, theater screen. So on that theater screen, from a single light beam, you get different actor images, some animated images. So those all are data, right? But they are transmitted as what? Light signal only. Understood? So this is what WDM. Light signal is transmitted using a common channel. So different light signals are transmitted using common channel, means those light signals are combined as a single light beam. Then that light beam is transmitted to the demultiplexer. The demultiplexer will retrieve various light signals from a combined signal. So this is the what? WDM, similar to FDM. Understood? So once again I will explain the prism theory here. So what happens in prism is, so in prism, what happens in prism is, for a prism kept like this, a white light beam is passed like this. So prism will divide that light beam into various light signals. White light is divided into various colored signals, and those colored lights are transmitted through another reverse prism kept in reverse direction. So that prism will combine those all into a white signal like this. So this is what simple concept of WDM, wavelength division multiplexing. Hope you understood. Thank you.